Spectacular moments grace our skies rarely, but on April 8, 2024, the cosmos delivered. A total solar eclipse of unparalleled magnitude swept across North America.
What you're witnessing is the moon in its orbit around the Earth, precisely between us and the sun. And this is going to happen fast.
Yet the darkness was only part of the wonder. Fiery solar events exploded alongside it, making it a true celestial masterpiece. Join us as we delve into this extraordinary event and its impact. The Great North American Eclipse. On April 8, 2024, a remarkable celestial event unfolded. A total solar eclipse cast its shadow across North America. Dubbed the Great North American Eclipse, it captivated onlookers in parts of Mexico, the United States, and Canada. As the moon momentarily obscured the sun, a narrow band of the continent experienced daytime darkness. Those within this path of totality witnessed a breathtaking sight. The sun's delicate corona, usually hidden, shimmering in the dimmed sky. The eclipse embarked on its mesmerizing journey in Mexico, making its first landfall on the Pacific coast at approximately 11:07 a.m. As the moon's shadow danced across the country, it crossed into Texas around 1:27 p.m., carving a path through the heart of the United States. States fortunate enough to fall within this narrow strip of totality included Oklahoma, Arkansas, Missouri, Illinois, Kentucky, Indiana, Ohio, Pennsylvania, New York, Vermont, New Hampshire, and Maine. Each location along the path experienced a unique duration of totality, ranging from a fleeting moment to a breathtaking 4 minutes and 26 seconds in areas like Nazas, Durango, Mexico, Kerrville, and Fredericksburg, Texas. As anticipation built for this rare celestial alignment, millions of eclipse enthusiasts flocked to prime viewing locations along the path of totality. Cities, towns, and even remote areas braced for an unprecedented influx of visitors, all eager to immerse themselves in the moon's shadow and witness the awe-inspiring sight of the sun's outer atmosphere, the sun's hidden fury, prominences, and the solar maximum. During the total eclipse of April 8th, the moon's silhouette perfectly aligned to reveal the sun's hidden fury in the form of prominences, immense structures of glowing, electrically charged plasma that arched gracefully above the solar surface. These otherworldly formations embody the complex and dynamic nature of our star, a dynamism fueled by the sun's powerful magnetic forces. Prominences are born from this intense magnetic field, which can trap and shape the hot, ionized gas of the solar atmosphere into massive, twisted structures. These celestial sculptures can extend tens of thousands of miles into space, dwarfing even the Earth in size. The temperatures within prominences are relatively cool compared to the surrounding corona, allowing them to emit the characteristic pinkish hue that captivates eclipse observers. The visibility of prominences during this eclipse was particularly remarkable due to its occurrence near the peak of the 11-year solar cycle known as the solar maximum. During this phase of heightened magnetic activity, the sun's complex magnetic field becomes increasingly turbulent and unstable, giving rise to more frequent and larger prominences. This increased activity allowed eclipse observers to witness a mesmerizing display of these colossal plasma structures dancing across the sky. The solar maximum is a period of intense solar activity, driven by the cyclical reversal of the sun's magnetic field. As the magnetic field lines become more tangled and distorted, they can snap and reconnect, releasing enormous amounts of energy in the form of solar flares and coronal mass ejections. This heightened activity also fuels the formation of prominences, as the twisted magnetic field lines can trap and suspend the solar plasma within their loops and arches. The study of prominences during this eclipse offered invaluable scientific insights into the sun's magnetic field and its interactions with solar plasma. By observing these structures in unprecedented detail, astronomers could gain a deeper understanding of the processes that govern solar activity and the complex dynamics of the sun's atmosphere. One of the key aspects of prominence formation that scientists are eager to investigate is the role of magnetic reconnection. This process occurs when oppositely directed magnetic field lines come together, break, and then reconnect, releasing a tremendous amount of energy in the process. Magnetic reconnection is thought to be a primary driver of prominence formation, as it can heat and accelerate the solar plasma, causing it to rise and form characteristic loops and arches. Another area of interest for scientists studying prominences is their potential impact on space weather. When prominences become unstable and erupt, they can release vast quantities of solar material into space, sometimes in the form of coronal mass ejections. These eruptions can have significant effects on Earth's magnetic field and technological infrastructure, making the study of prominences crucial for predicting and mitigating the impacts of space weather. Coronal mass ejections. The total solar eclipse offered a rare glimpse of the sun's dynamic nature. Coronal mass ejections, powerful bursts of solar material, and magnetic fields erupted from the sun's atmosphere. These colossal expulsions, often spanning millions of miles in size, are among the most powerful and dynamic events in our solar system, capable of ejecting billions of tons of solar plasma into space at speeds that can exceed 6 million miles per hour. CMEs are intrinsically linked to the sun's magnetic field, which can become twisted and distorted as it interacts with the churning, electrically charged plasma of the solar atmosphere. When these magnetic field lines become too tangled and strained, they can explosively snap and reconnect, releasing a tremendous amount of energy and propelling vast quantities of solar material outward in a spectacular display of cosmic fury. During the eclipse, fortunate observers had the opportunity to witness the breathtaking beauty of a CME in real time as it unfolded against the darkened sky. These eruptions often appear as enormous, ghostly spiral structures, their delicate tendrils extending far into the sun's outer atmosphere. The ethereal grace of a CME belies its immense power and potential impact on our planet and its technological infrastructure. When a CME is directed towards Earth, it can have significant consequences for our world. As the massive cloud of charged particles and magnetic field collides with Earth's own magnetic field, it can trigger geomagnetic storms, disturbances in the near-Earth space environment that can disrupt satellite operations, interfere with radio communications, and even damage power grids. The aurora borealis and aurora australis, the mesmerizing light shows that dance across the polar skies, are also visible manifestations of the interaction between CMEs and Earth's magnetic field. The study of CMEs is crucial for understanding and predicting the effects of space weather on our planet. By observing these eruptions during events like total eclipses, scientists gather insights into the processes that drive their formation and propagation through the solar system. One of the key factors affecting a CME's impact on Earth is its speed and direction. CMEs that are directed toward our planet and travel at high velocities are more likely to cause significant geomagnetic disturbances. Scientists use a combination of ground-based and space-based observatories to track the trajectory and speed of CMEs, allowing them to provide early warnings and forecasts of potential space weather impacts. Another important aspect of CME research is understanding the role of magnetic reconnection in their formation and acceleration. As with prominences, magnetic reconnection is thought to be a primary driver of CME eruptions, as it can release enormous amounts of stored magnetic energy and propel solar material outward at incredible speeds. By studying the magnetic field structure and plasma dynamics of CMEs, scientists can develop more accurate models of their behavior and improve our ability to predict their effects on Earth. This eclipse, occurring during the solar maximum when CME activity was expected to be heightened, offered a rare opportunity for scientists to study these phenomena in unprecedented detail. By combining observations from the eclipse with data from advanced solar observing missions, such as NASA's Parker Solar Probe and the European Space Agency's Solar Orbiter, researchers could paint a comprehensive picture of CME formation, evolution, and propagation through the inner solar system. Solar flares. Powerful bursts of radiation. Among the most intense and captivating phenomena observed during this eclipse were solar flares, powerful bursts of electromagnetic radiation that erupt from the sun's surface. These sudden and brilliant flashes of energy are among the most dramatic expressions of solar activity, releasing a tremendous amount of light, heat, and high-energy particles into space. Solar flares are intimately tied to the sun's magnetic field, which can become twisted and distorted as it interacts with the turbulent, electrically charged plasma of the solar atmosphere. When these magnetic field lines become too stressed and tangled, they can explosively snap and reconnect, releasing a staggering amount of energy in the process. This energy is then converted into heat, light, and motion, propelling high-energy particles and radiation outward at nearly the speed of light. During the eclipse, observers were treated to a mesmerizing display of solar flares, their brief but brilliant flashes of light punctuating the darkened sky. These flares, which can last from minutes to hours, emit radiation across the entire electromagnetic spectrum, from radio waves to gamma rays. The intense X-ray and ultraviolet radiation from solar flares can have significant impacts on Earth's upper atmosphere, ionizing gases and disrupting radio communications. Scientists classify solar flares based on their intensity, with X-class flares being the most powerful. These flares can release energy equivalent to millions of hydrogen bombs exploding simultaneously, making them some of the most energetic events in our solar system. The total eclipse, occurring during the solar maximum when flare activity was expected to be heightened, provided an ideal opportunity for scientists to study these phenomena in greater detail. The study of solar flares is crucial for understanding the complex dynamics of the sun's magnetic field and the processes that drive solar activity. By observing these flares during the eclipse, scientists could gain valuable insights into the mechanisms of magnetic reconnection, the primary driver of flare formation. Magnetic reconnection occurs when oppositely directed magnetic field lines come together, break, and then reconnect, releasing an enormous amount of energy in the process. This energy can heat and accelerate solar plasma to incredible speeds, producing the intense radiation and high-energy particles associated with solar flares. By studying the magnetic field structure and plasma dynamics of flares, scientists can develop more accurate models of their behavior and improve our ability to predict their occurrence and impact on Earth. Citizen Kate, 2024. One of the most ambitious and scientifically significant endeavors associated with the Great North American Eclipse was the Citizen Continental America Telescope Eclipse Citizen Kate 2024 project, a groundbreaking initiative that aimed to harness the power of citizen science and advanced technology to create an unprecedented, high-resolution view of the sun's corona during the eclipse. This Citizen Kate project brought together a vast network of amateur astronomers, students, and professional scientists from across North America, all working together to capture a continuous, detailed record of the sun's outer atmosphere throughout the duration of the eclipse. By strategically positioning observers along the path of totality, from Mexico to Canada, and equipping them with standardized telescopes and cameras, the project sought to create a seamless mosaic of the corona, revealing intricate structures and dynamics that have never been seen before. At the heart of this Citizen Kate project was a fleet of specialized telescopes, each fitted with a state-of-the-art digital camera capable of capturing high-resolution images of the corona in rapid succession. These telescopes were carefully calibrated and synchronized to ensure that the images captured at each location could be seamlessly stitched together into a single continuous view of the corona. In addition to the telescopes, the project also employed a suite of advanced scientific instruments, including spectrographs and polarimeters, which allowed researchers to study the composition, temperature, and magnetic field structure of the corona in unprecedented detail. By combining these measurements with the high-resolution images captured by the telescopes, scientists could construct a comprehensive, three-dimensional model of the corona, revealing the complex interplay between the sun's magnetic field and its outer atmosphere. One of the most exciting aspects of this Citizen KT project was its emphasis on citizen science and public engagement. By involving amateur astronomers and students in the data collection process, the project not only expanded the scope and reach of the scientific endeavor, but also fostered a sense of excitement and ownership among participants. Through a series of training workshops and online resources, the project organizers equipped citizen scientists with the knowledge and skills needed to operate the telescopes and cameras, ensuring that the data collected was of the highest quality. As the eclipse unfolded on April 8th, the Citizen KT project sprang into action, with hundreds of telescopes and cameras pointed skyward, capturing a dazzling array of images and measurements of the corona. The data collected during the eclipse was then transmitted to a central processing facility, where a team of scientists and computer experts worked to stitch the images together into a seamless, high-resolution movie of the corona. The resulting 60-minute film, captured in stunning detail and clarity, provided an unprecedented view of the sun's outer atmosphere, revealing the intricate dance of magnetic fields and plasma that shape the corona. The path of totality, strip of daytime darkness. As the Great North American Eclipse traversed the continent, it carved a narrow path of totality, 125-mile wide strip of land where the sun was entirely obscured by the moon. Within this path, day turned to night, and the sun's ethereal corona burst into view, creating an unforgettable experience for all those fortunate enough to witness it. The path of totality became a magnet for eclipse enthusiasts, drawing millions of visitors from around the world to cities and towns along its route. The eclipse's journey began in Mexico, with the path of totality first touching the Pacific coast and then crossing into Texas. As it traversed the United States, the path of totality passed through 13 states, including Oklahoma, Arkansas, Missouri, Illinois, Kentucky, Indiana, Ohio, Pennsylvania, New York, Vermont, New Hampshire, and Maine. Each location within this narrow corridor experienced a unique duration of totality, ranging from mere seconds to a breathtaking 4 minutes and 28 seconds. Some of the most favored locations for viewing the eclipse were Nazas, Durango, Mexico, and Kerrville and Fredericksburg, Texas, where observers were treated to an impressive 4 minutes and 26 seconds of total darkness. Other cities along the path, such as Dallas, Texas, and Cleveland, Ohio, also drew large crowds eager to experience the awe-inspiring sight of the sun's corona and the eerie twilight that engulfed the landscape. The varying durations of totality along the path added an extra layer of excitement and anticipation to the eclipse experience. Those who positioned themselves in the heart of the path, where totality lasted the longest, had the privilege of immersing themselves in the moon's shadow for an extended period, allowing them to fully appreciate the sun's delicate outer atmosphere and the profound sense of connection to the cosmos that such an event evokes. The 2017 eclipse. While the Great North American Eclipse shared some similarities with the 2017 eclipse that captivated the United States, there were notable differences between the two events that made the 2024 eclipse an even more remarkable and highly anticipated occurrence. One of the most significant contrasts was the timing of eclipses relative to the solar cycle. The 2017 eclipse occurred near the end of the solar minimum, a period of reduced solar activity characterized by fewer sunspots, solar flares, and coronal mass ejections. As a result, the sun's corona during the 2017 eclipse appeared relatively subdued, with fewer intricate structures and less overall brightness. In contrast, The 2024 eclipse took place near the peak of the solar maximum, a time of heightened solar activity. During this phase, the sun's magnetic field becomes more complex and dynamic, giving rise to a greater number of sunspots, solar flares, and coronal mass ejections. This increased activity translated into a more visually spectacular corona during the 2024 eclipse, with intricate streamers, loops, and plumes of glowing plasma extending far into the sun's outer atmosphere. Another notable difference between the two eclipses was the apparent size of the moon and the resulting duration of totality. Due to the elliptical nature of the moon's orbit, its distance from Earth varies over time. During the 2017 eclipse, the moon was slightly farther from Earth, appearing smaller in the sky and resulting in a shorter period of totality. The maximum duration of totality in 2017 was 2 minutes and 40 seconds, experienced near Carbondale, Illinois. In comparison, the 2024 eclipse benefited from the moon's closer proximity to Earth, appearing larger in the sky and creating a longer period of totality. The maximum duration of totality in 2024 reached an impressive 4 minutes and 28 seconds, experienced in parts of Mexico and Texas. This extended period of darkness allowed eclipse viewers to more fully immerse themselves in the experience and provided scientists with valuable additional time to study the sun's corona and associated phenomena. The path of totality also differed significantly between the two eclipses, with the 2024 eclipse offering a wider path and greater accessibility to a larger number of people. The 2017 eclipse path stretched across the United States from coast to coast, with a width ranging from 60 to 70 miles. In contrast, the 2024 eclipse boasted a path width of 100 to 125 miles, encompassing parts of Mexico, the United States, and Canada. This broader path of totality in 2024 meant that a greater number of cities and towns fell within the moon's shadow, making it easier for millions of people to experience the magic of totality without having to travel significant distances. Major population centers like Dallas, Texas, and Cleveland, Ohio, were positioned directly in the path, offering residents and visitors alike an unparalleled opportunity to witness the eclipse in its full glory. The increased accessibility of the 2024 eclipse path, combined with the heightened solar activity and longer duration of totality, made the Great North American Eclipse an even more incredible and widely anticipated event compared to its 2017 predecessor. Scientific advancements, the promise of new technologies. The 2017 eclipse sparked a surge of public interest in astronomy and science education, inspiring people of all ages to explore the wonders of the universe. Building upon this momentum, researchers and institutions redoubled their efforts to study the sun and its effects on Earth, leading to significant breakthroughs in solar science. One of the most notable advancements was the development of new solar-observing spacecraft and technologies. NASA's Parker Solar Probe, launched in 2018, became the first spacecraft to touch the sun, providing unprecedented insights into the sun's outer corona and the origin of the solar wind. Similarly, the European Space Agency's Solar Orbiter, launched in 2020, began capturing high-resolution images of the sun from a unique vantage point, revealing never-before-seen details of solar phenomena. These missions, along with ground-based observatories, provided scientists with a wealth of data to study during the 2024 eclipse. By combining observations from multiple perspectives, researchers could construct a more comprehensive understanding of the sun's magnetic field, the formation of prominences and coronal mass ejections, and the dynamics of the solar atmosphere. Advances in adaptive optics and image processing also allowed for sharper and more detailed views of the sun's features during the eclipse. These technologies, which correct for atmospheric distortions and enhance the clarity of astronomical images, enabled scientists to capture stunning high-resolution photographs of the corona, prominences, and solar flares. The development of new spectroscopic and polarimetric instruments allowed researchers to study the sun's magnetic field and plasma dynamics with unprecedented precision. These tools provided valuable insights into the processes that drive solar activity and the mechanisms behind the formation and evolution of solar features. Eclipse chasers and astronomy enthusiasts, prime viewing locations. The Great North American Eclipse was not just a celestial wonder, but also a cultural phenomenon that drew millions of eclipse chasers and astronomy enthusiasts to prime viewing locations along the path of totality. These dedicated individuals, armed with telescopes, cameras, and a palpable sense of excitement, converged on cities, towns, and remote areas, all eager to immerse themselves in the moon's shadow and witness the awe-inspiring sight of the sun's corona. As the eclipse date approached, communities along the path of totality braced themselves for an unprecedented influx of visitors. From major metropolitan areas like Dallas, Texas, and Cleveland, Ohio, to smaller towns and rural regions, local authorities and residents worked tirelessly to accommodate the surge of eclipse chasers. Hotels were booked months in advance, campgrounds were filled to capacity, and makeshift viewing sites were established in open fields and parks. The anticipation was palpable as Eclipse Day dawned, with millions of people positioned along the path of totality, ready to witness the celestial spectacle. As the moon began its journey across the sun's face, the landscape was transformed, with eerie shadows and a noticeable drop in temperature. Fascinating crescent-shaped shadows, created by sunlight filtering through the leaves of trees, danced across the ground, adding to the otherworldly atmosphere. As totality approached, a hushed silence fell over the gathered crowds, punctuated only by the occasional gasp of amazement. The sky darkened, and the sun's corona burst into view, its delicate tendrils stretching out into the inky blackness. For those precious moments, time seemed to stand still, as eclipse chasers and astronomy enthusiasts alike stood transfixed, marveling at the raw beauty and power of the cosmos. The experience of totality was profoundly moving for many, evoking a deep sense of connection to the universe and the wonders that lie beyond our earthly existence. As the moon's shadow raced across the landscape, the collective sense of awe and wonder was palpable, uniting people from all walks of life in a shared moment of cosmic appreciation. For eclipse chasers, the Great North American Eclipse of 2024 was the culmination of years of planning and anticipation. Many had traveled vast distances, crossing oceans and continents, to be in the right place at the right time. Challenges, safety measures, and public awareness. The Great North American Eclipse was not only a celestial wonder, but also a logistical challenge that tested the resilience and preparedness of communities along the path of totality. As millions of eclipse enthusiasts flocked to prime viewing locations, the sudden influx of visitors strained local infrastructure and resources, leading to chaotic traffic congestion, overloaded communication networks, and a depletion of essential supplies like food, water, fuel, and medications. To mitigate the risks associated with the eclipse and ensure public safety, state and local authorities implemented urgent measures, such as issuing disaster declarations, accessing additional resources and funding, and closing schools. These proactive steps allowed communities to better manage the challenges posed by the eclipse, while minimizing potential disruptions to daily life. One of the most critical aspects of eclipse preparedness was educating the public about safe observation practices. Observing the sun without proper eye protection, such as certified solar eclipse glasses or telescopes equipped with solar filters, can cause permanent eye damage, including solar retinopathy. This condition occurs when the sun's intense ultraviolet and infrared radiation burns the retina, leading to symptoms such as blurry vision, dark or missing spots in the central vision, pain, and light sensitivity. In severe cases, solar retinopathy can even result in permanent vision loss, To prevent these risks, officials and experts launched widespread awareness campaigns, emphasizing the importance of using approved solar viewing devices that meet the international safety standard. These filters are designed to block the sun's harmful rays, allowing safe observation of the eclipse. Experts also warned against using makeshift filters or ordinary sunglasses, as they do not provide sufficient protection against the sun's radiation. Schools, libraries, and community organizations played a vital role in this educational effort, hosting workshops and distributing informational materials to help people understand the potential hazards and the proper methods for viewing the eclipse. Many of these institutions also provided free eclipse glasses to their communities, ensuring that everyone had access to safe viewing equipment. By working together to inform and protect the public, these organizations helped ensure that the eclipse was not only a breathtaking spectacle, but also a safe and enjoyable experience for all. Thanks for watching, and we'll see you in the next one.